me this week. And again, trimester ends on, I think, I want to say it's the last day of February this year. So we're real close to being done. I will tell you that Chapter 8 test will be the last major test we have on this trimester. So be important to do well on that. A lot of you guys are in good shape right now. If you can solidify a good grade on that last test, you would really be locking down your grade here towards the end of the second trimester. Okay. So again, I think this section's pretty easy. I think 8.4 has been the one section of all of these that has been the toughest. All right. And other than that, everything else has been pretty easy. So well, it's some 8.4 stuff pretty hard. But today, guys, I want to get rolling with some of the stuff in 8.6, which is titled Describing Pairs of Angles. And what we need to ask ourselves is the following. How can you describe angle pair relationships and use these in description to find angle measures? Okay. A lot of vocab today, and the vocab is going to be very important in terms of what the question is asking. So if you don't understand the vocabulary today, you're not going to know what the question is asking. So I think as we go through the vocabulary today, we'll be pretty good. So goals to answer our question, we need to be able to identify these words, complementary and supplementary angles. And then identify what's a linear pair and vertical angles are, what linear pairs are and what vertical angles are. Okay? So let's hit this vocabulary kind of hard here. How about I volunteer to read my complementary angle definition, please? Volunteer to read that for me, please. Thanks, Hannah.
Two angles whose measures have a sum of 90 degrees. Each is a complement of each other.
Okay, so two angles. How many angles again, guys? Two angles. And together they add up to how many degrees?
90.
90. So if I start and say, hey, here's an angle of maybe, here's an angle of maybe 30 degrees. What's going to complement that angle?
Angle of 30. Oh, wait.
How many, Kayla? 60. And what's your reasoning?
They add up to 90.
You bet. 30 plus 60 would be 90. So those are examples of complementary angles here. All right? You have an angle. You have an angle. 10 degrees. 10 degrees. What's 10 degrees complement? 80. All right? Complement 10, you would need 80. All right, supplementary. Exact same thing. Only difference is you have two angles whose measures have a sum of not 90, but
180.
180 degrees. Each is a supplement of each other. So as an example, I'll put this obtuse angle up here of 140 degrees. How about how about supplement? 40 degrees. 140 plus 40 is going to be how much? 180, right? Okay, so 40 degrees. So I'll put this down here like so. So these are supplements of each other because 140 plus 40 is going to be what value? Well, 180. Okay? So I'm thinking of an angle. You ready? 100 degrees. Whoop. Yep.
Do you want me to just erase it and say
Yep. Yep. All right. 100 degrees. That's my angle. What's its supplement? 100 degrees. How about a supplement? 80 degrees, right? 80 degrees, right? Okay, so I think we get this. You know how I remember it? 90 comes before what value numerically? 180. Just like in a dictionary, complementary would become before supplementary. So that's how I kind of remember that, okay? All right, definition of adjacent angles. Definition of adjacent angles. They are two angles that share a common vertex and side, but have no common interior points. Adjacent just means side by side. Here's an example of adjacent angles. Okay, how many angles form the big angle, guys? Two. Do they share the same vertex? Right here they do, don't they? Okay, and they also share a common ray. And I'm just going to go ahead and say, well, these are rays. Adjacent angles are two angles that are joined together. And they share that side. That side that I highlighted green, that's the shared side. That's the shared side that adjacent angles have in common. Okay? So adjacent just means side by side. All right? I don't like the definition of linear pair. Is that okay?
Yeah.
I'm going to change this. I'm going to change this. Are you ready for this? Linear pair means the following. I'm going to put this down here. I'm going to write down adjacent. So it means two angles that are what by what? Side by side. It's going to be adjacent angles that are going to be supplementary. Supplementary meaning how many degrees again?
90.
Okay, they're going to be adjacent supplementary angles. Supplementary again is how many? Not 90, but 180. Guys, what kind of an angle has a 180 degree measure? Straight angle, right? So 180 degrees is going to be a straight line. So a linear pair, simply put, is something where if I have two angles put together, the two adjacent angles, angle 1 and angle 2 right here, form this straight line here. That didn't work out the way I wanted it to. Angle 1, angle 2. Does that look better? Angle 1 and angle 2 form that straight line right there. Okay? So linear pair means they're adjacent, but they're just going to form a straight line when put together. Okay? Good there?
Yes.
All right, and then the last one, vertical angles. What the heck are vertical angles? Well, vertical angles, key word to underline here is this. I always think of vertical angles as opposite angles. One angle across from another. So if I have two lines that intersect like this, and if I had angle 1 and angle 2 right here, I would say angle 1, I'm going to back it up this way. I'm going to say angle 1 and angle 2. Angle 1 and angle 2 are what we call vertical or opposite, if you will. Vertical or opposite angles. Angle 1 and angle 2 are vertical angles, okay? That means they're across from each other, okay? So guys, in a nutshell, I think that some of those diagrams really help bring out what the definition is of each of those terms. They're going to be important to understand as we move through the examples here today. Before I start jumping into those 5 examples, anybody have any questions about the vocab today? Feel pretty okay with it?
Yep.
Okay. The stuff that we look at example-wise is really pretty darn easy today. Pretty darn easy. Okay. Let me know if you have that down right now. Anybody need more time with this page? Max is writing furiously. His pen is smoking over there. Very good, buddy. Okay. Anybody else need more time? All right, let's take a look at this first example. All right. So guys, up here in example 1, I've provided 4 angles up there, 4 different measures, 28 degrees, 108 degrees, 72 degrees, and 62 degrees. It says within those drawings there, they want you to name a pair of complementary angles. So I'm going to say, all right, we need a pair of complementary angles. So I'm going to write this right here. We'll abbreviate. 2 angles that complement each other. Pair of supplementary angles. Supplementary. All right. And a pair of adjacent angles, side by side. All right, so in here, guys, there's 4 different angles. We need to come up with a pair, meaning 2 angles that are going to, first of all, be complementary. Complementary meaning adding up to how much? 90. So maybe I just jot this down right here. Okay, we've got to get up to 90 there. Ain't 2 angles in there that would add up to 90 degrees? What do you think, Taylor?
62 and 28.
62 and 28. You bet. Some people get tricked on this. They see the 28 and the 72 and they automatically think, oh, 90. But that's not true. That actually adds up to a 100. So exactly right. Do you guys agree that Taylor 28 plus 62 is 90, guys?
Yes.
Okay, 28 and 62. Those are complementary angles. How about your supplements in there? Which 2 angles are supplements of each other? What's supplementary mean again? 180 is the value that they add up to. Can you think of 2 up there? 108 and 72, right? 108 and 72?
Yeah.
Okay, so 108 and 72. Good, Hunter. Okay. Which angles are adjacent to each other?
108 and 62.
108 and 62. Now, guys, I want to show you something. If I start putting letters in here like this, like A, B, and C, I could also write stuff in there. Instead of saying a 28-degree angle, I could have said angle ABC, and then where that 62-degree angle is, maybe this is like W, X, Y, and Z. Where I had the 62-degree angle and the 28-degree angle, I could have also said, instead of seeing these numerically, we could say, you know what, angle ZXY was that 62-degree angle, right? I could say angle ZXY complements angle ABC. Okay, so I can also label stuff by variables instead of degree measures, all right? So as you're going through the assignment, when you get that tomorrow, just know it might be a numerical value that they're looking for, or they might want a name of a certain angle. Okay? Are you okay with that? Okay with that? All right. So guys, instead of saying 108 and 62 on the adjacent part, instead of saying 108 and 62 on adjacent, I could say angle WXZ is adjacent to ZXY. Okay? Are we cool there?
Yep.
Clear?
Crystal.
Crystal. Two Good Men.
Yep.
Great movie. Hannah, did you order the code red?
You're right, I did. What? You're recording, so I couldn't say it.
Okay. Example 2. Very simple to do, guys. Example 2. It says angle 5 is a, what's the word here, gang? Angle 5 is a, what's the word? Of angle 3. And I tell you angle 3 is how many degrees? 53. So complement means that the two angles have to add up to 90 degrees. So simply put, guys, right here, to find this measure of angle 5, my measure of angle 5 right here is going to equal the 90 degrees I want totally. To find the missing angle, take 90 and subtract the known angle. What is the known angle measure there in example A? What is the known measure value in example A? So we're going to take 90 and subtract how much? 53. So that makes the measure of angle 5 here. How many degrees? You bet, 37 degrees. Okay, measure of angle 5 is 37 degrees. Okay, how about a volunteer to explain how B works? B says angle 4 is a supplement of angle 2. Measure of angle 4 is 29 degrees. Find the measure of angle 2. Supplement. What value are you going to start with? 180. What do you have to subtract out to get your unknown angle? 29. So, Chloe, if I understand you correctly, you're saying the measure of angle 2 equals that 180, because the angles are supplementary, minus my known angle of how much? 29. What's that equal, kids? What's that equal? How much? 151 degrees. Very good. So if I ask for supplements and complements, can you do it? All right, I hope so. This is pretty doable, I think, today. Okay? This is pretty doable. All right? Questions on page 2. All right, let's run this last page right out of the building. This will be pretty easy, I think. Think of there's an example that's probably most important. It's example 3, so you might want to put a star by that. Okay, example 3 says the following. It says, hey, you have a leaf. You look at a leaf. Anybody ever looked at a leaf real closely? It has like those little veins in there, doesn't it? And it says the veins in a leaf form a pair of, what's the word? The veins in a leaf form a pair of Supplementary angles, meaning 180. It's two angles put together that form a straight line. Would you guys agree with that? It says one angle is given by the expression 7x plus 13 degrees. So I'm going to put that right here. And the second angle is given as an expression 25x plus 7 degrees. Okay. We are to find the measures of each angle. All right. Now we've kind of looked at stuff like this already. Maybe you guys can give me a direction as to where I would start here. Anybody have a thought on what to do here? Make an equation. I agree with that. So what are we going to do to make an equation? How am I going to write that equation for this? Anybody? You want it, Chloe? All right, what's your equation?
180 equals 7x plus 13 plus 25x plus 7.
So you're saying if I take the two angle expression, 7x plus 13, and add that to 25x plus 7, in other words, I'm adding the two angle measures up, right? And that's going to equal what value again? Why 180? Definition of supplementary angles. Very good. All right, so how about some terms to combine? Since Valentine's Day is getting closer, we should probably put things alike together, right? 7x and 25x is 32x. And then how about the 13 and the 7? What would that become? A plus 20, kiddos? All right, let's two-step our way to the end. Subtract 20, so I've got 32x equals 160 now, right? Guys, how many times will 32 go into 160? 5, very good. And we're done, right? Who said no? Why aren't we done? Well, no angle measures, we're going to have to go back into each expression for the measure of each angle and substitute what value? 5. So that angle on the left, that angle on the left is given as an expression 25x plus 7. So we're going to go 25 times what, kids? Plus 7. All right, 5 and 25 is 125. Add 7 more to that, you're going to have 132 degrees. Okay? Now again, guys, I'm going to say this over and over and over again. When you get your answers in the end, is there a way to check to know if you're probably right? Most of these diagrams like this, you bet. There are ways to know if you're right. Second expression, 7x, so 7 times 5 plus 13. Let's see, help me with my arithmetic. 7 times 5, 35. Add me 13 more, 48. Hey, check it out, guys. 132 and 48. Does that indeed add up to 180? It does. So right here, guys, the measure of this angle right in here, that angle is going to be 132 degrees. Measure of this angle right in here, going to be 48 degrees. Again, this is stuff that we kind of looked at in the last section. They weren't just adding up to 180 or 90. You've got to make sure you understand the vocabulary so you know what to set your expressions equal to in terms of an angle value. Okay? Feel okay on number 3? Okay with that? What's that? I don't know. I don't know. Same guy that works at Ford probably put it in.
Oh.
All right. Down here, example 4, I want you to label up some angles like this. Call us 1, 2, 3, 4, like I've done there. Call us 5, call us 6, 7, and 8. Just like I've labeled the following. Our job, identify linear pairs, identify vertical angles. I'm going to kind of form a T-chart to get this in our notes. I'm going to be a little heavy on the left side. Okay, the left side I'm going to call this right here. I'm going to call them my linear pairs. And on the right side, I'm going to put VA for vertical angles. Okay?
Are you magic, Marshall?
Am I?
Yep.
I'm a mathematician. So you could call me a mathematician. So yeah, I guess. You okay with that?
Yes.
Slater thinks I am. Slater's having a hard time staying awake back there. That boy didn't have enough coffee this morning, did he? Stunts my growth.
That's why you're so short.
All right, here we go. Guys, right here, I want to identify all linear pairs. Now, if you recall, linear pairs are two adjacent angles side by side that form a straight line. So let's just kind of get started with this right here. I'm going to kind of show this example first. Give me a pair of angles put together that forms a straight line right off the bat, showing what you need to see right up here. Two angles that are side by side that form a straight line. 1 and what?
2.
1 and 2. What's another pair that would form a straight line? 5 and 6. Okay, so let's get rid of this. Let's get rid of this. I'm going to write these down. 1 and 2, they are a linear pair. Also, 5 and 6 are a linear pair. Okay? What if I went slanted this way? How about 2 and 3? Are 2 and 3 adjacent, first of all? Do 2 and 3 form a straight line? Therefore, are 2 and 3 a linear pair?
Yes.
They are. Let's stay over here in this set. 2 and 3. What's another one within these set here? 1 and 4. And I also heard somebody say 3 and what? 3 and 4 and 1 and 4. Okay. All right. So over here on the right, we already have 5 and 6. There's 3 more linear pairs in there. What's another one, please? I'm sorry. Show me your hand quick. What's one, Brandon?
5 and 8.
5 and 8 would work. I agree. So we have 5 and 6 going left to right. 5 and 8 on the left side of that slant. 6 and 7 would work. What else would work? 8 and 7. Good. 8 and 7. So understand what linear pairs are. Okay? Then, they also want us to identify pairs of vertical angles. Angles right across from each other. I'm going to start with the first angle. I'm going to go 1. What's vertical of 1? 3. 1 and 3 are vertical angles. In that set, also, what else are vertical of each other? 2 and 4. So we've accounted for everything there. How about this second set over here? What's vertical? 5 and...
7.
And then finally...
6 and 8.
Okay, so if they ask you to identify those, can you handle that?
Maybe.
Linear pairs, vertical angles. You understand the difference between the two?
Yeah.
Linear angles, right next to each other, form a line. Vertical angles, angles across from each other. Okay? I know I'm going quickly through this. Are you with me right now? Okay, let's get this last example done. We'll call it a day here, okay? How about volunteer to read example 5 for me, please? Thanks, Brandon.
2 angles form a linear pair. The measure of one angle is 8 times the measure of the other angle. Find the measure of each angle.
Okay, so let's draw this out. What do these 2 angles form first?
Linear.
A linear pair. So describe to me what I should draw first. Describe to me what I would draw first. A linear pair. How many angles?
2.
2. And when put together, they form a...
Straight line.
So how about something like this? Whoa! Will that look like a linear pair? Okay. Says one angle is 8 times the other angle. Okay? So it sounds like we're going to have a big angle and a small angle. Would you guys agree? Okay. Let's call this angle over here. I don't know what this is. I'm going to call that angle X right there. I have no idea what it is. Okay? That's the small angle. How many times bigger is the big angle than the small angle? 8 times. So guys, if I listed that small angle as 1x, what's 8 times 1x going to be to give me? It's going to be 8x over here, right? Is this angle 8 times bigger than this? So we have to find the measures of the two angles. So here we go. What's 8x and 1x going to add up to? You'll have 9x. Numerically, though, by linear pair, what value are we going to set that equal to? What are we going to set this equal to?
180.
180. Good. So we'll have 9x equal to 180. Stay with me here, guys. Stay with me. Stay with me. What are you going to divide by? Divide by 9. What's your x value? 20. Good. Once you know your x value is 20, throw it back into each expression up here. What is 8 times 20 up here? How much? 160 degrees. What's this measure over here?
20 degrees.
First question, do they add up to 180 degrees? Second question, is 160 8 times 20?
Yes.
It's got to be right then. It's got to be right. Okay? So I'd say make sure you've got everything down here. We'll start looking at the assignment tomorrow in class. And you guys know you're off the 5th hour next, right?
Yeah,
Fifth
what's
hour
your
next,
fifth hour
okay.
last hour?
All right, you guys have a great day.